Hey everyone, in this video I'm going to give you a brief introduction to the lab that we're going to be doing in class for the next class period. So this is a track just like the demonstration I did in class, and what we're going to do is we're going to use carts. We're going to smash the carts together, and we're going to check that the momentum of the system before the collision is the same as the momentum after the collision. This is called conservation of momentum. We're going to check in this lab. So first, I'm just going to tell you the lab setup, and then give you a little introduction to how the data analysis is going to work. So basically, we want to know, because we need the momentum, we want to know the mass and velocity of the carts before they collide. We can measure the mass, but the velocity comes from motion sensors. So we have these green motion sensors. We're going to put one on either side at the end of the track, and each one is going to measure the velocity of one cart. Now, to get the data from the motion sensors, we're going to use something called Logger Pro, which is a computer program, and we're going to have some interfaces that connect up to the computer. So, real quick, the motion sensors connect to a controller like this. There's a wire that goes from each of them to the controller, and then there's a USB cord that goes from the controller to the computer. So I'm going to connect those up right now real quick. Okay, so that's the final setup. I've just connected the controllers to the controller here, and then to the computer. So now I'm going to go to the computer and show you how data taking is going to work. Okay, so now I'm going to show you how to use the data acquisition software we're going to use. This software runs on our MacBooks, which I'll bring into the classroom for us to use. It also runs in your iPads. So if you would like to try it on your iPad, I'm very happy with that. I assume it's harder to use on the iPad than it is on a laptop, but please, if you want, give it a shot. It'll be good for us to see if the iPads work in that manner. Everything's set up already. I've already got all the plugs plugged into the computer and stuff. So first thing you need to do is find Logger Pro, which is what it's called. So click the little search thing, type Logger Pro, and hit enter. Program should open up. I have two controllers connected, so you should have two windows, which you see I do. Position 1, position 2, velocity 1, velocity 2. So it's going to measure the position, velocity of the carts for both cart 1 and 2. So the first thing we need to do is notice that there's a sign problem in my setup. I have one controller this way, one motion sensor facing this way, one motion sensor facing this way. So motion in this way is going to be positive for this one. Motion in this way is going to be positive for this one. If we have a coordinate system, we want one direction to be positive and one direction to be negative. We don't want to flip them and combine them. So that means that our setup is wrong. This is going to think this way is positive, this way is going to think this way is positive. That's bad. So we can flip that in the program. So go up to Experiment, and then Set Up Sensors, Show All Interfaces, click one of the interfaces, and then Reverse Direction. So just remember that you've got to do this before you take that. Reverse direction, close it, and we should be good. So now I'm going to do a run, and we're going to see what the data looks like. I'm going to ask you to do a variety of different things, both of them moving, one of them stationary, one of them moving. Just for the demonstration, I'm going to do one stationary and one moving. You click the green button right here when you want to start taking data. Okay, and then I'm going to collide them. Looks like a good collision, not too fast, seemed to happen a pretty regular way. So we can come over here and look at the data. I'm going to click on the velocity plot and then click this A up there. That makes it zoom in. Okay, so how are you going to understand this data? Well, first of all, this is velocity versus time. Velocity is on this axis, time is on this axis. One cart is blue, one cart is red. The blue cart was stationary. It was not moving. You can see that in the chart. It has a velocity of 0 for the first 1.25 seconds or something. And you can see the red cart had some changing velocity, but then right here the velocity was constant. So right here and right here, the velocity is constant. That's right before the carts collide. But then you can see that the velocity changes. So the velocity is changing because the carts are interacting with each other. They are colliding. When the carts are done interacting and they're stuck together, then that's this line right here. You can see that that's also a roughly constant velocity. It's roughly a flat line. So when we're going to check the conservation of momentum law, we're going to check that momentum is the same before and after. We want to find the velocity of the two carts before and after. So the velocity of the cart right before the blue cart right before the collision is right here. Velocity of the red cart is right there right before the collision. Velocity afterwards, both carts are stuck together. They have the same velocity. It's right there. I can actually read this straight off the plot if I just use this tool right there, this little intersecting line thing. Then I can go down and I can slide it along and I can read the velocity right there is almost 0 and the red velocity is negative 0.367. So you can just read the velocities right off the plots. That's the velocity before, that's the velocity after. And you can use that to check that the law of conservation of momentum is held. So that's the overview of the lab. I'm going to have a few more details and how I want you to do the analysis in class, but that should give you an overview and get you started thinking about what you're going to have to do when you get into class on Tuesday. Great. Thank you very much. Everyone have a good weekend.